Hi again. Welcome to Hard-Boiled Synthesis, Lecture 7. Today, we're continuing the extraction phase, which is by far the most awful part of the meta-analysis. It's a phase where you develop grudges against certain researchers and they report information. But you learn a lot through the process. And for me, for my experience, is I learn how to more effectively report things in my own studies. I mean, there's nothing more aggravating than trying to read through the methods section and just not being able to figure out what exactly was done. And for meta-analysis purposes, when we're trying to code studies, trying to extract data, clarity is key to processing a paper efficiently. And so today, hopefully, the two papers that I'm going to extract data from is going to be straightforward, nice and easy. And I got 27 of these to do. And I've done one. It's time for me to do two more. Now, I think what I'm going to do, just like what I did with the PDF stuff, is I am not going to record myself extract data from 27 studies. I mean, it took me almost an hour in Lecture 6 to do one. Mostly because I was talking a lot and telling you guys random stuff. And so I haven't quite decided yet how much effort I'm going to show you guys in terms of extractions, but I'm going to do a bunch so that you guys get a feel for some of the challenges involved and some of the quick solutions, workarounds to gaps of information in a study. Maybe I'll have a few studies where I get to impute information, fill in gaps. But by most part, I'm just going to be coding studies. If you remember, my coding criteria are very simple. I'm not actually coding for quality. I'm coding for meta-analysis, downstream, factors that could impact the variability of studies. So like temperature, humidity, these are things that impact the efficacy of repellents. And so they may be moderators of study outcomes. In the last study, just to recap, I couldn't find what were the experimental conditions, the ambient experimental conditions for the experiment, but after reading over the study again, it was outlined in the study. So for example here, study number 2 that I coded, the Whitney Qualls study testing catnip repellents, but mixed with other compounds to facilitate the release, as opposed to a solvent, which is like when you go to the store, you buy DEET. DEET is with like some sort of alcohol, and you spray it on, and then the smell diffuses consistently for some time. That's why these things kind of last for a couple hours. I think if DEET by itself would not last for hours, and so you need to add these things to it to extend the repellency effects. And so here the study is experimenting with different approaches to extend the repellency effects. For example, right, so they use coconut oil or lotions and infuse it with catnip. I mean, I always thought it would be a cool thing if, like, say, for example, sunscreen companies would double up sunscreen plus DEET. I mean, the beaches here, some are beautiful by the ocean, but sometimes you go on like an island beach, like a honeymoon island here in Florida off St. Pete. Beautiful place, but there is a ton of mosquitoes. You're on a beach on off the Gulf of New Mexico, and you're just getting eaten by mosquitoes. And so you got to double up. You got your sunscreen and you got your insect repellent. Why not have the two together? There must be some reason why you don't have the two together. Excuse me. And nonetheless, maybe this is why everything is taking too long. I'm just talking too much. I'm going to supplement the missing information right now into the Excel file. So right now, see, they do talk that presumably the study was done in a large room with a temperature and humidity of 60%. So, right, so there's consistency in the trials. Now the report, the temperature ranges from 22 to 23 degrees Celsius. That's not a useful number for me to add to the spreadsheet. And there's no way to analyze ranges. And so I'm gonna take the average of the two so that later on I can do analysis. And so let me just quickly add this stuff to the data set. Right, I said not reported, but that's not true. 22.5 and then 60% humidity. Right? So again, I really like that study, even though there were gaps of information. Overall, it's good. And in total, I extracted 6 contrasts, 6 effect sizes, because they had a huge diversity of controls. They had positive, negative controls, procedural controls. I could have extracted more effect sizes from this in terms of the contrast among the controls. Does the positive control differ from the procedural controls? I didn't do it here because that's not informing the main question of the course, which is whether catnip is better than DEET. Now, these contrasts also don't answer that question, like the contrast between copper tone and DEET. Copper tone, yeah. Copper tone by itself. And, where am I going with this? I think, okay, it's fine. Okay, I need to move on. Excuse me. So, next step is study number, I got it written right here, study number 24. So that's really next on my list of coding and extracting data. Let me update this silly little thing that I have on the side here that's keeping track of my progress. Right now, only 1 out of 27. But hopefully this one right here will be fairly quick to complete. So I got my Excel file going. I got the PDF going. Let me just quickly modify the spreadsheet here so I could see things. Always see the headers and the study ID. All right, right on. And what I'm going to do is I'm just going to change the color of this study, the background color, make it a little shaded so that I never confuse it with the other study. So this one is study 24. That becomes a study ID. First things first, let's collect information on the mosquitoes. This study is a little different from the other one in that it's testing a electrospinning polyvinyl fibers. So I guess it's like a fabric of some sort that they created, and maybe they infused it with the repellent. I mean, there's a ton of these kinds of studies. Maybe the purpose of this is to create like a bed net that's infused with repellent activities. So not only do you have like a physical barrier protecting people from mosquitoes, but you also have the added benefit of a repellent, further repulsing Mosquitoes, I mean, this stuff is a big deal because mosquitoes, depending on where you are in the world, they do vector nasty things like plasmodium, causative agent of malaria. And so, having multiple layers of defenses is really the way to go. The challenge is like, it's expensive. I think it's really expensive to kind of develop these tools. And so I very much appreciate the effort these research labs are doing to try to create something that could save lives. Okay, so the goal of this study, we got a fabric, it's infused with catnip. Is that ideal for what we want? Sure. Because again, our focus is understanding whether or not catnip is an effective repellent. The medium in which it's released is going to vary a lot by studies. I mean, we already got one study that did not do a conventional repellency test with just straight up using the essential oil of catnip versus DEET. Right? It infused catnip with lotions. This study here, we also get a slight variation in the conventional repellency test. Here they're looking at some sort of fabric and whether or not, and I guess they probably use a diversity of repellents in the fabric, and catnip was included in that bunch. All right, so the goal is to just find species of mosquito tested. I'm just going to quickly code all of these criteria that I had outlined in Lecture 6. So we got a lot of microscopy stuff, looking at the structures of the fabric. Mosquitoes, there we go. Characterizing the repellency of integrated mosquito repellents. All right, so we got Anopheles sensu stricto here. I'm just going to copy and paste that right there. Next is to find the age of the studies, age of the mosquitoes. Climate conditions, nice. Okay, so that's all stuff I'm going to paste. Mosquitoes were kept under phase-shifted scotophase. Ugh. Scotophase is like jargon associated with daylight cycles. And then you got temperature and humidity. They were kept in boxes. I'm not keeping track of how they maintain the colonies of the mosquitoes. Maybe that's going to be a shortfall in the long run, but I feel like that's not totally crucial to what we want. They were fed with glucose. But all this stuff is like, this paragraph describes how they maintain the mosquitoes, like the source of the mosquitoes. I want to know about the mosquitoes used in the experiment. So the mosquitoes intended for these experiments were placed in separate cages as pupa. They had sugar, but received no blood meals. Okay, so not totally starved. Right, so they were given sugar. Sugar is like a simulation of nectar. Mosquitoes need to eat. Females also get blood meals, but they drink nectar. That's how males don't drink blood. They drink nectar. Day before the experiment, 5 to 8 day olds. Okay, I could just start filling in the Excel stuff. So 5 to 8 day olds. They weren't starved. It doesn't look like they were starved. Both laboratory experiments took place in the last 4 hours of the scotophase, a period in which females are highly responsive. The environment conditions where the repellents were data logger. Temperature was maintained at 26 degrees. Okay, I gotta put all that stuff in here. 26. There's that's nice. They put like a little error around the temperature, but they don't indicate whether that error is like standard deviation or like what's the unit of that error. Maybe that's totally not important. It doesn't look like they talk about humidity of the thing, so that's going to be not reported. It is not an arm and cage trial. Instead, they have the fabric in the cage. So it's like a similar experimental design, but except for a human, they have a piece of fabric that's infused with the compounds. So how do I describe this? I'll call it just fabric in cage. Maybe not fabric in cage. What would I call this? Infused fabric. There we go. Infused fabric in cage. That is certainly not a technical way to describe the experimental design. But I think, if I come back at this a year from now, I'll understand what that means. That it wasn't a human in the cage. It was fabric. Okay, starved. Let me just double check to see if they actually say starved. Mosquitoes intended for the experiments were placed in separate cages. They had 6% glucose but retrieved no blood meal. The day of the experiment, were placed in cages with access to tap water. The day before the experiment. Okay, so they did prevent the mosquitoes from eating anything with substance, like water is not. I mean, you could be starving and still have access to water. So I'm going to chalk these up as starved mosquitoes. Okay, this is going by pretty quickly. We got the species, the age, starved, infused fabric, temperature details. How many mosquitoes were put in a box? Mosquitoes intended were placed in separate cages. They were does not say. Or maybe it's in the bioassay. Vertical landing bioassay. Okay, this is where it gets kind of complicated. Vertical landing bioassay was used to determine repellents. Assays were in a cage. They got a nice little diagram. Strips were impregnated with Eppendorf tube stuff, solution, 1 milliliter. They this is a cute diagram. Okay, so they heated up the fabric. I guess you kind of have to do that, right? You need something for the mosquitoes to be attracted to, and heat is one of the many dimensions in which mosquitoes are attracted to things. And so here because no humans are involved, they didn't pump CO2, they didn't do. Other studies will use like artificial blood. You warm up the artificial blood as an attractant. Here they heated up the fabric. Not too sure if that's the best way to go about it, but whatevs. I mean, I'm just gonna code this. Temperature of the gaze was kept at 35. Comparable temperature to human skin. They say it right here. Okay, so they're trying to simulate human conditions. This resulted in high attraction of female mosquitoes to the warm area. Nanofiber mites were... Repellency samples were measured by releasing 10. Okay, no, so all that stuff that they said beforehand was not related to the actual bioassay, the repellency test. So I got to fix... So 7-day-old... mosquitoes were released in the cage. I mean, do they have that? So I had 5 to 9. If I would have taken the average of that, that would have been 7. But because they were more explicit, I'm gonna just put that there. Landings, they counted the group of 10, which is the number of mosquitoes in cage, which is considerably less than the 200 beforehand. I can't remember. The World Health Organization guidelines is like you put a ton of mosquitoes in a box. I mean, in the hundreds. 10 I think is just, it may take a long time for anything to decide to land on you. The trade-off with having a ton of mosquitoes, again, is with those negative controls. You got a ton of mosquitoes, something will land on you very quickly. So maybe that's what their goal here is. They were optimizing the number of mosquitoes so that there was some time in which something would land on the hot fabric. All right, let's start coding some of the repellency stuff. Repellency details. I'm just going to look for a figure here to help me cut corners. That's usually the quickest way to... They use chili, also chili, as a repellent. There we go. Categorizing repellency. Okay, so they have one control. They have chili, catnip, and permethrin, which is one of these other synthetic compounds, an alternative to DEET. So again, bummer for the study, it's not using DEET as a comparison. So if I was really strict in my inclusion criteria, I would totally drop this study. I mean, it's not contrasting DEET. But I'm going to include it anyway because it does provide some information about catnip, even though the ideal contrast is not DEET. And presumably there's going to be other studies that will not use DEET. They'll use some other type of conventional repellent chemical. And so why not be inclusive with all that in my synthesis? I mean, even though DEET is the gold standard, there's certainly other ways to go about it. And I think with like fabrics and bed nets, the permethrin is a popular one to use. They don't infuse it with DEET. I imagine because the DEET is more unstable, maybe in the long run, it just doesn't retain its properties, whereas permethrin might be like a nice long-term defense of a fabric. I need to look that up. That seems like an interesting thing. Okay. So number of landings by 10 mosquitoes during 8-minute observation times. We got 2 concentration of microcapsules. So we got different in PMD. So I got to look up what PMD is. An undescribed abbreviation in the figure. That's a negative mark on my end. Always should try to make the figures as independent units in a publication. Most people just go straight to the figures, so why not be helpful and provide all the information they need to interpret that figure? So now I'm stuck trying to go through the manuscript to figure out what a PDM is. Okay, PVA was supplied by Sigma Ultras, chili and catnip essential oil, as well as microcapsules made from melamine resin were supplied by Devon Chemicals. Okay, so it's a resin, PMD resin. So that figure presumably is just talking about how much resin they put. How much resin concentration of resin and mosquito landing. Maybe here they're testing the concentrations of PDM microcapsules. I am totally confused by this. They show the capsules, but they're not describing whether or not the capsules are infused with repellency things. Because they have it over here. They have the repellent. I guess the idea is the capsules themselves have repellency effects. My guess is that PMD capsules include the repellency things. That's super duper. Super duper confusing. Mechanical properties of nanofibers incorporated with different concentration of PMD microcapsules, chili, catnip. A, B. I mean, they're always keeping the repellents separate from the microcapsules. Trying to figure, introducing PDM microcapsules, permethrin, chili, and catnip into PVA did not significantly change the tensile strength. Wow. All right. I'm just going to go back to the abstract here. Recently, different repellents were electrospun. Okay, so this microcapsule, they are describing this methylene diol microcapsule. It's a separate repellent. Okay, I don't need to pay attention to that at all. And then what I want, of course, is the catnip oil. Okay, sheesh. That's confusing stuff. And it's good because then I don't have to extract that whole concentration stuff of that one chemical. Okay, incorporated repellent. Really, this is what I want. We're going to want catnip. Doesn't seem that they describe the species of catnip again. They're just like flat out, we got catnip oil. Let me just verify that. Paraffin, bioassays. Yeah, I don't see any species description here of what catnip is. I mean, that's a shortfall again. You should try to figure out, at least look at the jar that you extracted the essential, you purchased the essential oil, and it should indicate the species. Okay, well, that makes it easy for me, I guess, in the long run when it comes to coding this stuff. We just got catnip. It's an essential oil by itself. I think it was 8% concentration. Let me double check. That was in the plot. Plot was way down. %, by weight. So let me just add that unit here, just because it was like a weird one. And then I'll have to come back and standardize all these concentrations. Right, we got infused fabric, anopheles. What else we got? Procedural. Okay, so let's, what kind of control it is. Don't say what the control is in the figure, the identity of the control. And so now I'm left kind of scouring the methods again. Repellency of sample were measured. Landing was defined a total period in which a mosquito made contact. Walking, hopping around landing, plateaued, short takeoffs, immediately followed by landing were included in one landing. A new landing was recorded when a mosquito had left the plateau. Landing shorter than 1 second during which no probing were ignored. Catnip oil. Samples were placed at the bottom page. Bioassay. Vertigo were determined. Strips were impregnated with attractive compounds. Comparisons were made between all treatments in addition to comparison between the control, but you don't describe what is the control. Case of catnip emulsifier, smooth surface. I need to now go into the text of the results to figure out what exactly the control is. Have reduced significantly compared to the control, but what is the identity of the control? Is it nothing? Is it DEET? Is it just a piece of fabric with nothing on it? I mean, no description of the identity of the control. That is, I'm going to assume it's a negative control. And that it was just an untreated fabric. And as a note, I'm going to write assumed. And it's like 0% concentration. Now I guess I could investigate whether or not it was a positive or negative control depending on how, if there was any repellency effect in the control. But looking at the figure, the controlled average landings is pretty high. And so this to me indicates it's just a straight up warm piece of fabric and the mosquitoes are landing on it because they're attracted to it. But it's not clearly described. I'm just making this assumption. The response type is average number of landings. It is in no. What do I got here? Response units. There's no. It's a count. All right, let's put in these numbers. Now, quickly, like there's a figure here where I'm going to extract the data from the figure here, but in some random convergence, there's also the table of the data. There's like a redundancy of information here. I'm not I'm not complaining. I mean, like, you got the numbers here. I'm always going to take the numbers. But this is a neat example in seeing if I could, what do you call it, reverse engineer those numbers from the plot. And so before I do any of that, I'm just going to plug in these numbers here. And then I'm going to, as just a silly exercise, extract data from the plot to see if the numbers match. I mean, there's no reason why they shouldn't, but you know. Okay, first things first, right? We have an average, and then we have a reporting of an estimate of variability, but we don't know the identity of that variability. Is it a standard error? Is it a standard deviation? And now again, I gotta scroll to the methods section to see what they mean by that. The two-sample statistical test was used to analyzing the effect of adding the repellent. An effect was significant when the p-value was smaller than 0.01. Okay, so I'm modifying the alpha value here. I'm not too sure why you would do that. Comparisons were made between all treatments. Maybe because they're doing multiple comparisons, they modify the alpha value. There's some funny business going on here. Okay, so I don't know if it's a standard deviation or standard error. However, I do remember that this was one of the few studies where there was a fig share data set. I'm not going to do that today, but if there's the raw data reported, then I could estimate the standard deviation, which is what we need. But I'm going to plug these in to the Excel table quickly. We got the negative control, which I'm presuming it's blank, and then we have the positive control, which will be the permethrin. I'm just totally going to ignore the chili. So the catnip response time was 12.8. And then the E, but I'm going to put a question mark around E so that I could come back to it later. And then the sample size, they say it multiple times, it's 9. I mean, what you're going to find with these repellency tests is the sample sizes are going to be so small. I mean, it's super rare to see a sample size greater than 15. I mean, at some point it was decided that you don't need much to detect a repellency effect. It's brutal. That's an unfortunate design flaw of these experiments is as there's not heavy emphasis on sampling and issues associated with sampling error. But meta-analysis, you know, we account for that. Control mean 25.6 with an unknown error, presumably sample size of 9. Boom. Okay, let me just double check to see. Infused in fabric. I'm going to copy this entire line and repeat it because we got two effects. We got the positive and the control group contrast. So we have a positive and then we got permethrin, which was at 8 WT%. The mean response time is the same for both because it's always going to be catnip, but then the control value is going to change. To a really small value because, again, it's a positive control. 0.6 with an unknown All right, so this paper is officially coded. Let me just double check all the rows if everything is yeah, okay, so I'm done with this paper because they reported conveniently the table of this small bar plot. But for fun, just to end, I mean, how long have I been talking? All right, 40 minutes. Just for fun, in the end, I'm going to extract the data from the table and then compare the two. I mean, this is going to be brutal. If I spend an hour on an individual study, I mean, what is that, 27 hours? I got to stop doing this. So, yeah. Let me rethink my strategy here. But the goal is to now numerically extract or reverse engineer the values reported in this bar graph and see if they reflect the actual numerical values in the table. And so I'm going to use R, and I got another one of these Tickle TK GUIs, which help me extract data from plots. I mean, there's a million different ways in which you could achieve this. There's 2-3 packages available that allow you to do this. Basically, all these tools out there, web plot, digitizer, data thief, I forget what all this stuff is called. They're just rulers. They're really just rulers where they're measuring distances of things in an image. You could print this stuff out and use a ruler and figure out the numbers yourself. You could do it in Adobe Acrobat. Adobe Acrobat has a little ruler widget where it allows you to measure the distance between two things. PowerPoint, you could do the exact same things. You could have draw a line and then measure the length of that line. And so there's a zillion different ways to go about this. When it's like a little bar graph like this, I mean, you do not need a high-powered digital tool to extract data from this. When there are maybe potentially 50 bars, then that becomes tedious. Other plots are way more tedious, like scatter plots, where you just have many dots and someone's fitting a line through that. It takes time to point and click every one of those dots, and so maybe some automated tools is useful for that. But for most problems, I feel like in at least for the repellency stuff, it's always going to be a sweet little bar graph. So we don't need anything fancy to measure the distances between things in an image. But I'm going to use this Tickle TK GUI, which is something I developed. I don't remember when. It's a front end to some of the data extraction tools of Metagear. Metagear allows for some semi-automated tools and manual extraction. I don't think anybody's ever used Metagear to do that kind of stuff. Mostly because you got to parameterize the semi-automated tools. You got to say, oh, the things you want to detect is small. Maybe it has a different color. You need to code all that stuff, and that just turns people off. I mean, all they want to do is just measure things. They do not want to have to deal with the automated tools. So the front end was meant to be a shortcut to all of these parameterizations of the semi-automated tools. The GUI works, but it's buggy. It's a memory. There's a memory leak in it. And so if you use it a lot, it just chokes up your entire system. So I never released it, but I'm going to use it today because I'm lazy. It's what I'm familiar with. And if I'm going to spend an hour on each individual study, I just got to use what I know to move on with things. All right, so I opened up R, and let's open up this tool here. Is it going to work? If it doesn't work, I'm just going to move on. Try again tomorrow. There we go. It's there. Let me double check to see if you guys can see this. You can. Okay, so this is like the silly interface. At the time I was all into like juicing stuff, and so I got like this little button you press to try to semi-automate the data extractions. It gives you like a little progress meter. Oh, I detected the x-axis, I detected the y-axis, and now I'm trying to process the data. And so here I just have like a default scatter plot here. And so if you press this giant button, I don't quite remember what happens. It'll try to extract the data from that plot. So like, okay, it detected the y-axis, it detected the x-axis, but it wasn't able to detect the points because the figure's so small here. The figure's small, the points are small, so you could like reparameterize the model and then try it again. And it should, there we go. So it detected each individual point. It colorizes things that it couldn't differentiate. The plot is so small, it's hard to separate points. A human could probably make decisions on separating those points. And so in this GUI here, right, we got this little magnifying glass that could like help you eyeball those things. I'm just going to close this right now and just insert the graph that I'm supposed to extract from. Enough fooling around with these tools. I think you guys get the idea. You don't need a sophisticated technology to extract data from 3 bars. I mean, you got to be realistic about that. All right. So let me bring up the thing. I need to take a picture of this image. It's small, and so I'm just going to rescale it a bit, just so the image is bigger and easier for me to measure stuff. So I'm just going to do like a quick screenshot. And then copy and paste it in Paint. And then, you know, that's an opportunity to kind of clean up the image. Like if I was doing like an automated extraction of this table, that embedded table is a problem because it's just noise when you're trying to detect objects in a graph, right? And the semi-automated tools isn't really smart enough to differentiate between all that stuff. Okay, so you guys can't really see me cut and paste this stuff because it's just too hard for me to, I'm just trying to get this done quickly. All right, I'm going to save that. Give it a name of the study, 24. $24. Okay, something's not working right here. All right, I did take the image screenshot. What did I call the file? 24. Now I gotta find it. Not on my desktop. There it is. Okay. Whew. I'm just learning how to figure out where these files end up. Okay, now our studio is like, what is happening? There we go. I just got too much going on. All right, so I think I just call it 24. All right, so let's just go back to our studio and then open up this image that I copied and pasted out of the PDF. And let's just quickly extract some data and compare it to that table, and then I'm done for today. I think this is super silly that it's taking me so long to just do this activity. And it's not happy with me. I mean, it's my fault I'm doing all this on whew, I did put it so big. Let me make it smaller. Let's try this again. There we go. That makes more sense. All right, so we got our little table here. And now we're just going to measure the lines, the distances between the top and the bottom of the bar to get a numeric value. I did not need to do this at all for this study. But it is something that will come up, and so I just thought maybe I'd show you guys one way to go about it. We're going to go under manual extraction here. I'm going to add the axes. We don't need two axes here because the x-axis is not meaningful. That looks about right. The range of the axes. Oh, wait a second. The range of the axes is a little weird here. Freak, it's never straightforward. Okay, so we have a bar plot, and the zero is floating. It's floating in the air, which means that if this was a true Cartesian plane where the values on the plot, I'm getting mad about this, where the values on the plot are meaningful, then that means whatever part here would be negative values, right? Because we have stuff that's drawn below zero. I mean, ggplot does this all the time. It divorces the axes right? Kind of separates them a little bit to make things look nicer. But it messes up the way we extract data from figures. And here, like, I don't know. It's like, so we got a ruler, right? We measure this scale, 35. And I guess if this is evened out, it would be minus 2.5. That's what this point right here would be, minus 2.5. But I'm going to assume that it just starts at 0, and this is just like an error that they wrote here. So the minimum is 0, the max is 35. Let's measure some of this stuff. I'm going to simultaneously measure the length of the bar and the error. For the controls, skip the chili. Do the catnip. And then finally do the positive control, which is the permethrin, which is a small little bar. Okay, let's just look at these extractions here and see if they how they match with what was reported in that table. And the numbers are off, right? They are clearly off by about 2.5, because the axis is all weirded. The scale of it is bizarre because you're including negative numbers in the plotting. And so the values depicted by the bar graphs are not representative of what's the scale. So I'm just going to modify the scale, redraw the axes. I mean, I'm sorry, guys. This is supposed to be straightforward stuff, and it's just not working out. So I'm going to measure things now at the 0 point. And see if the actual numbers come back. Let's see. I'm not too sure if you guys see this. Okay, you do see it. Okay, so these values... these values are closer to what's presented in the table. Okay, so if this was a automated tool to extract the data, the values would be flat out wrong because the axes are not scaled appropriately, right? This is just one of the challenges of like data extraction from images. There's so many deviations from best practices, and just this little issue of like not having that the axes are divorced from one another, that you include negative values in a plot, means that you have to rethink the way in which to properly scale the numerical values. So my values are close, right? We got 25.7, 12.7, 3.07. I mean, that's close enough. And then the errors, which are standard in units of standard deviations, are also... well, I don't know what the units are. They don't report the units again. But they're close. 5, 3, and 6. So they rounded off on their end. I got slightly more better values. Anyway, okay. This has got me a little ticked off. just a little pet peeve, of like best practices of presenting results in plots. Man, just follow the rules. Have meaningful axes. Okay, so I gotta rethink the way in which I'm gonna do this. I'm not gonna spend an hour for each individual study. That would be a total of 27 hours, a whole month worth of lectures. And so I'll talk to you guys again on tomorrow, and hopefully by then I'll have figured out a better strategy to do this. All right, take it easy.